I'm Dave Derrick. I'm a research hydraulic engineer at the Waterways Experiment Station in Vicksburg, Mississippi. And I've been doing this for about 32 years. Seems like a long time, but it's a great job. I think it's the greatest job in the world. I get to fly everywhere. I've got to work hundreds of streams in all different situations. I worked on the Mississippi River for about 19 years, and then I've helped fix every kind of stream, ditch, big stream, little stream, river, steep, shallow, wide. Um, some of them really messed up. A lot of urban areas and things of that nature. So, but I'm not familiar with the streams in Hawaii, and these are a little bit different situation. So this week we were out here before with the conference and listened to a lot of learned people at that time, and got a lot of background. And then we've been out walking streams, which is probably one of the best parts of my job, and learning and listening to all the information, all the different experts and people that we're meeting on the street. You know, and we're kind of a big group, so it attracts a little bit of attention. When we're walking through some of these areas, and people would stop us and ask us what we were doing, and we'd try to tell them. And Carol Wilcox was saying that I should start at the beginning, and I guess that's kind of hard for me. I guess I'm used to really teaching and doing seminars with professionals that are really used to a lot of stream terms and stream terminology and functions and so I guess I'll try to start at the beginning. I'm not sure. The flying in and taking a look at these streams, these watersheds are pretty unique. Just with the fact that you've got very heavy development in the flat areas and the coastal areas, and then as you get up into the mountains, it seems like it's really inaccessible and very, very steep. Seems to be a lot of runoff, and that's it's been things have been changed. The talking to the local experts, and I'm more of a stream person than a botanist or a biologist. You know, they're saying that when you look out at these big forests, that 99, 98, or 99% of these are non-native species. These are introduced species that came from somewhere else, and that's really hard to it's really hard to eliminate and get rid of those, and it's hard to comprehend all the minute differences and maybe some even large scale differences. Just with the fact that just typical rainfall, and it depends on what was here before, but a lot of the native trees and shrubs are designed or function to intercept a lot of that rain and slow it down and hold it on their leaves. And I'll use an oak tree as an example because I know the numbers on that. But an oak tree that's a quarter of an acre in size can hold 1,000 gallons of water on its leaves. So that's a lot of water that's sitting there, and might, if it does hit the ground, it's been intercepted and slowed down and stopped, and then it'll drop down, and you won't get as much problem with the raindrop splash where the raindrop will come way out of the sky, hit, and impact the earth and kind of splash and dislodge some of these finer particles, and then those move downstream or downhill or into the stream. So just that one fact right there, you could have a lot of extreme differences in the amount of water, even if you get the same water falling out of the sky, the amount of water that's going to reach your stream. And then a lot of these trees, and I guess some were seeded in the 20s and 30s with the reforestation, they're really fast growing vegetation and trees, and that's always a problem, because if it's fast growing, then it's usually not very strong, and they typically can get moved over or fallen over with wind, or they break easily. They don't live as long as maybe some of the other species. So you run into problems with that. A lot of those trees, the non-native trees and shrubs, don't have as extensive of a root architecture as the native trees do, so it's not holding the soil together as well. And then you get into things, just how many leaves are going to drop off the trees, and is that going to form a really dense kind of a layer on the soil itself, a forest duff, where even when the rainfall and water does get down there, then it's going to get, it's like a mulch. It's a natural mulch, and it would get absorbed by that material, and then it wouldn't be able to run off and go down the hill. So you've got probably some big changes in your water delivery to your stream. And those areas are, like I said before, are really inaccessible, and they're going to be real hard to mitigate some of those changes. And we don't even understand exactly how much of a change that is. So there's going to have to be, anything that you do, you're going to have to work forward from the good science. And in a lot of cases, the good science, we don't possibly have the answers yet. But there's a lot of different groups, and I'm sure you know more about this than I do, that are working toward those answers. So that's kind of the one part of the watershed, and then the other part's the urban area. And we got to walk, where were we? Manoa Stream at the University of Hawaii, and we got to go down underneath the bridge and the underpass and walk up a little section of that. And that is, if you haven't walked through there, it's fantastic. That's an eye opener after looking at all these concrete lined channels and some of the other things that we saw this week. That's a great riparian area, the area that's next to the stream that's connected to the stream hydraulically. There's space down there. And one thing, when you go into these projects and you're taking a look at watersheds or stream stabilization or stream restoration, you always want to have the luxury of space. If you've got some space to work with, you can really do a lot of things. And of course here, the first thing you look at and you say, where's the space? There isn't any space. And Rich and I were walking out last night, and I said, when they planned and built these communities and developed the houses and the urban areas, residential areas, commercial areas, if they would have stepped back from the stream 100 foot on both sides and left that completely alone or left that stream alone, we probably wouldn't have a job, for starters, or we wouldn't be working here. We'd work someplace else. That's crazy. So you've got a lot of problems with it. And then the stream straightening is horrific. That's a single function project, and a single goal is to get the water out of those urban areas and down the hill and into the ocean. And it's unfortunate because back when these things were straightened and lined with concrete, smooth and steep and as fast as possible to get this water runoff down to the ocean, they didn't realize all the impacts. And even a lot of them were just learning over the last couple decades, and it's still ongoing. So that's a huge problem. And I typically don't work in water quality and stormwater runoff and flood damage reduction or flood reduction. I'm more into the restoration stabilization. So typically I'm working for the stream, basically. That's usually my client. Doesn't really matter who's paying me. That's just a personal point of view. So I'm going to try to make that stream work and function as well as I can within a number of different constraints. And here, wow, we are up against it. We are just, when you start with a concrete lined channel and a straightened channel, there's just so many obstacles to try to get that into some kind of form or function. And one shining light this week was going to Manoa Park and looking at that stretch of Manoa Stream that folks had restored, sloped the banks back a little bit, a lot of vegetation, a lot of native vegetation. I was in heaven out there. That was just great. Was that y'all?
That was our project.
So cool. My hat is off to you. Fantastic. So you look at that and you say, man, that would be great to do that in other parts of the stream and the watersheds and things of that nature. And to do that, you're going to have a lot of people that are really, especially stream side, are going to have to buy into it. And you look at it and you say, well, how can you do that? Well, the first steps would be education on what a stream should do, how it should function, how it should meander, how it should move back and forth. When you're flying over an airplane, you're going to see some kind of a sine wave deal. And then there's another sine wave that you don't think about as much, but as it streams meandering around and it goes around the corner, it's going to go down deep, and you're going to have a deep, slower pool, okay? And then you're going to glide up out of that, or tail up out of that pool. And then it's going to go over a riffle, and then it'll go into a run. It'll go into another pool as it goes around that other bend. So these streams, they set themselves up, or they work themselves into a type of dynamic equilibrium where they function really, really well.